Hi all, welcome to my talk. In the next 45 minutes, we are going to discover stuff for implementing observability in Java-based projects. I'm Michael. I'm named Java Champion last year, working for a mid-sized consultancy in Germany called InnoQ. And we're working together with clients and build software there and do architectural work and such stuff. But it's not about me or my employer, so observability. Before we dive into code, and I'll try to show most of the stuff live, we will need to take a little bit of theory in beforehand. And I forgot, if you have questions or know something that I don't know, just try to interrupt me. I can't see the chat right now, but I will try to answer the questions anyway. So observability. Observability has some concepts. The first one is sources. So if we implement an application, we have multiple boxes who talk to each other, who have some communication ways, and each of that may be a source for observability stuff. And for example, this may be our systems that we implement or that we just have bought and run. That might be some infrastructure stuff as databases or queues. And if we zoom into one of the systems itself do have some layers. For example, for a typical Java application, there's the application, that's the code we wrote. There's the runtime, the JDK, and all of this is running on an operation system. And each of that layer is a source in itself. So it's not just the whole box that's the source. And inside a box, there may be multiple sources. So sources. The second concept we have to look at are signals. And signals is the stuff which are being emitted by a source. So every source in our whole system may emit some signals, and signals may be logs, metrics, and traces. And we will dive into that later. But one property of all the signals are the volume in which they occur. And metrics is the only signal that has a little bit a lower volume, and that's because they are aggregable. So if I have a metric how long something takes, I can sum up every occurrence and then divide it by the number of occurrences to get the average. So I don't have to store any metric occurrence, but I can aggregate them. And on the higher volume side are the logs. Logs are produced by every system, but they are not distributed from one system to the next. They stay inside that one system that emits it. And the last one are traces. Traces are request scoped, so a request produces a trace, but traces will be distributed. So one trace spawns across multiple systems, so they need to be connected. And these three are our primary signals. So what to do with the signals? And therefore there are agents, not a Java agent especially. It's more of a concept. And agents are some components that take the signals either by pulling them out of the source or by being sent from a source to an agent. And they may do some stuff like formatting or aggregation. And yeah. And then there are destinations. And destinations is the place where the signal getting sent to from an agent. So they collect all the signals of our whole system. Okay, so that are the basic content. This is the basic content and concepts. We have sources who emit signals, which are being collected by agents who ship them into a destination. And why do we bother? In the good old days, our system was just one component. And if I wanted to get or see the logs of this component, I did some SSH into the server. I know where the logs were stored, often in a log file, and I can cat it and grab there from an error, and I'm happy. But today, most of our applications are built in more smaller components, as a microservices architecture or even a monolithic structure. But we have multiple systems and components who talk to each other. And therefore, it's more complicated because I can't just SSH into one component. If I want to get an overview of the whole system, I would have to SSH into each of the components and look at the logs or the metrics or the traces. And why do I bother? Because I'm a developer. I'm not that interested in operations, and observability is more like like a topic for operations. So there are two concepts which are in right now. The first one is DevOps. Although I hate the wording on itself, the concept that development and operations have to come together and work together for producing a meaningful software is relevant. And there's the concept of calling shift left. So in the old days, concerns like security and operations were only thought very late in the development cycle. And a shift left means we have to shift these concepts from the later parts of the stage to the newer, to the earlier parts. So in a world where our clients expect systems to be online 24/7 and we're deploying to a cloud in a microservice architecture, we need to think about operations very early in the development lifecycle, and therefore even development needs to be needs to know the concepts of operations and of observability. And now I'll try to go into the IDE, and I will have first a look if there are any questions right now. Okay, so nobody asks. Okay, so for my example, I have a backend application which I will start, and a front-end application which I will start. Both are implemented with a Spring Boot, but that it's just the case because I'm most familiar with it. And the application does a very simple thing. The UI renders time leaf templates as a UI. And for most of the stuff, it will call the backend application over HTTP. And the backend application will use a Redis queue for storing stuff and retrieving stuff like it as a database. And the functionality is I can create a session. And I forgot to start Redis. Yes. Docker Compose up. Sorry for that. Let's try again. Create session. Yeah. And now I can at the session, I can store key value pairs. So it's name Michael and conference JCon. And if I transmit, I will see the session content, and it's deleted from the database. So it's a very simple case to not be too specific, but to have some communication. And when as you can see, the application is a little bit slow. That's on purpose. And if we look at the logs here from the back end and the front end, it's nearly nothing logged. So the first observability thing we can implement is logging. And logging is like you know it. I'm using here the simple logging facade for Java, which is the default of a Spring Boot project. But of course, you can use a real or direct implementation like Logback or Log4j2 or whatever you like. And it's even not specific to the programming language. So let's uncomment all the logging. And we can restart this one. And on this side. By the way, if it's too small, you can yell at me too, and I will then switch to presentation mode in IntelliJ to make it larger. Nobody yells. So now I have some logging statements, and if I now create a session and put a key there and transmit the session, you'll see there are some log statements like, hey, in the backend, the session controller says I'm creating a new session. And then the session service says, yeah, I'm creating a session and I'm updating a session, transmitting a session. And the front end has some logging as well. Yeah, okay, I will zoom in. But now both applications only log to their own standard out, and I don't have an aggregated view where I can see all logs. And for that, I will will take the next step, which is sending the log message to a centralized system. And let me just go into presentation mode to make it a little bit bigger. So the first thing we do for that is we will edit the configuration for our logging framework, which in this case is a logback or simple logging facade with logback as an implementation. And for that, I'll add a specialized appender, which in this case is a Loki appender. Loki is one possible system which can take logs and as a destination. And in this case, I've decided to log directly into an appender, which then will send the logs to the running Loki instance, which runs on my machine on localhost 3100. I've added some special things like static information, like an application name, and the level as metadata. Read markers we will come to in a few moments. And batch max items means every single log message is directly pushed to the server. This is not a production-ready configuration, but for a demo where I don't want to wait until the batch is full and is sent, it's necessary to do it that way. Besides the Spring configuration, the configuration itself, I will need to add the dependency too. Let's make it a little bit prettier. And I will have to stop the application and to reload all the Maven projects to take the dependency into play. And now I can start this again. Okay, so the backend is running. And now I have to switch to the front end. And here I will do the same. I will add the logging configuration. I will add the dependency. I will stop the application. I reload the Maven project and I will start again. So if I now transmit a new session, create session, 1, 2, 3, 1, 2, 3. we'll see the logging on the console is like before, but I can now go to Grafana, which is is one of the multiple front ends you can use for looking at various destinations. We can go into the Explore mode, and we will take Loki, because in Loki there are our logs, and of course I messed up. No last 5 minutes. Yeah, okay. And now we can see that our logs are stored here. And if I remove that filter and run again, I need to select at least a label. So let's say application, matches, observability, everything. Okay. So then let's remove it, and we just we can use level as info. So now within Grafana, we can see that there are the logs of the backend. So the backend session service says updating session, and the UI as well. So that's one place where all our logs are collected and can now be seen at a glance. And as you can see here, there are even specific fields like the application and the level that are the values I configured in the logging configuration as fixed values. So when using logs in a distributed way in observability, you try to make the logs structured so the information can be filtered on. Because I've used the fields, I was able to filter all the logs. So I just now I'm only seeing all logs messages that have a level info, and I could filter on the application. Yeah. And if you have information that is not static, then there are concepts too. So let me go into the we can stay in the UI. If I go into the UI controller, what I can do is I can use label markers, which is an implementation of the Loki appender. And I can provide this as a additional info to my log messages. So I can do it here and here and here. And if I'm now restarting the UI and that one, okay, should be running again. And let us store another value here. And now if I look at this one, I have another information as a separate field with a session ID. So that's a non-static information that I can add to a log statement. And now I would be able to even filter on this field and only see the log statements which have this session ID. So whenever there is relevant information that you may need to see at your logs, you can use this label marker or a map diagnostic context, which is supported by some log frameworks or other stuff. So each log framework has its own way, but there is a possibility for every logging framework. Okay, so let's remove that. So that's basically the logging part, nobody else. So we go on to the next part, which is adding metrics. So adding metrics in a Spring Boot application normally starts by adding another dependency, which is the actuator one. Spring Boot Starter Actuator contains multiple things for making your application production ready, and one of that is metrics. And we need some registry where the metrics are stored. And in this case, I've decided to use Prometheus. I think maybe most of you have heard about Prometheus. Prometheus is a system which stores metrics and make this queryable. And besides adding these two dependencies, I also need to add some metrics configuration. In this case, we expose another endpoint over Actuator, which is the Prometheus endpoint. So Prometheus collects our metrics in our system and provides an HTTP endpoint where the values are written. And we see at the end of the talk, there's another configuration of Prometheus which scrapes this endpoint and imports it into a database. I'm also including percentile histograms for some specific metrics. So a percentile is so you can do queries like how long do 70% of my HTTP calls take? And you not only have the minimum, the maximum, and the middle, but you have such buckets as 70% or 80% to do some more fine-grained calculations. I tag all my metrics with the application name, and every 10 seconds, the endpoint is refreshed from this stuff. So I've done this. I need to reload because I changed the dependencies, and I can restart the UI. And I will have to do the same for, where is it? For the backend. CD/ yes. We need the metrics. We need to stop the application. We need to configure it. And we need to restart it. Okay, and now I will do just a plain for loop, which creates sessions to generate some traffic in the system. So this called the front end and create a new session 25 times, which can run in the background. And because Prometheus now scrapes our metrics and will import them into its database, we can use Grafana to query this metrics. And for example, I have to copy this one. We can do a query like that, which does histogram quantile for that it uses the metric HTTP server request seconds bucket, which is one metric we are providing automatically because Spring Boot Actuator instruments our code and provides some default metrics. And we only will take the values of these metrics which belong to the observability UI application, which has the label method like equals to post and which are on the root URI. And if we run that query, we can see here that we have some metrics which are around what is it, 1.5 seconds over the last 15 minutes. Use over the last 5 minutes. I can just generate a little bit more. We need to wait a few seconds to have it refreshed. Yeah, and there are more points. So, without any advanced configuration, because of Spring Boot Actuator and the Prometheus support, our metrics are working too. And we could even see them on localhost /actuator /Prometheus. You can see how the metrics are written. So, for example, this is the metric HTTP client request seconds bucket, which we looked at from the observability UI. And there are some more labels. And the LE is the bucket. And this is the value. So here, this metric has a value of 43. And this is scraped by Prometheus and imported into its database. Okay, and now the last part. The last part are traces, and traces will give us the availability to look at requests flowing through our system. And for that, we need to extend the system, the dependencies. So we need another dependencies. We need the tracing stuff. And for this case, Micrometer has the concept of bridges. So a bridge, so Micrometer itself is just a facade. So it has no implementation. And the bridge bridges this API, this facade, to an real implementation. And in this case, we are using the OTel, which stands for Open Telemetry. That's a standard library. We could use Brave as well. So there are multiple implementations. And on the other side, you need an exporter, which exports the recorded traces from our system to a database, to a destination, which in this case is Tempo. And for this, we are using the OTLP exporter, which stands for Open Telemetry Protocol. That's a standardized protocol for traces. And we could use Zipkin here too. So Zipkin is just another protocol. Which one you need to use depends on which server you use. And we need to do second optimization. We need to do some configuration too. In this case, I will extend our logging pattern. So a trace ID and a spawn ID is logged too. And I will set the sampling probability to 100%. Because under normal circumstances, you don't want every HTTP request to be traced and recorded and to be sent to the database, because this would be too much traffic and too much stuff. So normally you will trace only like 10% of your calls and the error ones. But for this demo, I want to have every request traced to make it easier showable. So we have that. So we stop the application, we reload our dependencies, and we start it again. Okay. And now we do the same for our backend. So that's exactly the same in both projects. Reload dependencies and starting new. Okay. And now, if I do a for loop once again, we will create some more sessions. And what you can already see here in the local logs is now that in these parentheses, there are these two values which correlate to our new logging pattern level, which is a trace ID and a spawn ID. And this is in the UI. And now we should see for the same ID, the ATBB8 in the backend, a logging statement 2. 8 BB. Now here is ATBBD1. So you can use this trace ID to correlate calls in multiple systems, because we were logging in our logging system into Loki. And now if I once again Loki do our level info, we will see that for every log statement, there's the trace ID field 2. And now I could say trace ID is this one. Huh? Normally it should be queryable, but it won't. Okay. So this is all my fault for being a little bit nervous. So as you can see, we have this trace ID, or the logs are created. And the other thing you could maybe see is now here the trace ID says tempo, and tempo is the system which stores our trace. And if I click on this, and let's make this, we get to see the trace. So this complete line on the top represents the complete call from the front end until the back end. And we see it was a HTTP post to the slash of our UI. And that system did an HTTP post to the backend. And now the green line here represents the backend, who got the HTTP post and processes it. And now we can do some more stuff for okay, yeah, Jenny, how did the log get printed out? I've added the logging pattern here, and includes the trace ID and the span ID. And the %x, at least for logback, says take these values from the map diagnostic context, and they are put there by the Micrometer instrumentation. So Micrometer itself knows about, for example, has a web filter which will put the trace ID, which will generate a trace ID if there's none present, and put it into this map diagnostic context. And from this on, it will be available in the logs. And what we can now do a little bit more in the traces, if we switch back to the backend, we can include even some information which are sent to Redis. That is not currently the default of Spring Boot 3.1.5, but it may be in 3.2. Let me just import anything here. So in this case, I'm adding another bean, which is a client resource builder customizer that can be used to customize the Redis configuration. And I'm adding a Micrometer tracing adapter to this client. And the service name is Redis. And if I now restart my backend, Okay, and we will do more posts and switch to the browser. Close this one. Last 5 minutes. Run a query. UI. Let's take this one. Yeah, now you are able to see that here is another spawn within my trace, which is a Redis set. So now even our Redis connection is instrumented and will be part of the trace as a separate step. So here we can see we posted against the UI. The UI did a post against the backend. The backend received the post and issued a set command in Redis. So this helps us for debugging and how a request will flow through our complete system. And because we have these lines, you can even see where most of the time is spent. So it's a valuable tool for performance questions too. Mm. And we will do a last thing within our backend. If we are not, if we want to have more details, we can mark code, our own code, as such a span too. So until now, everything that is traced here is automatic detected by Spring and Spring Boot and Micrometer. And what we can do if we switch to the backend once again and go into our session ID generator, we can add here an observation, which is an abstraction from the micrometer tracing, a new, which says here is an important step that we want to record. And we need observation registry 2. So let's edit. And yeah, let's rebuild, which will restart the application. Yeah. Now we need to create a few sessions once again. And let's close this one, switch to tempo, and let's search for UI traces in the last 5 minutes. There is one. That's too old one. That should work. Why is it not included? So let's use the backend. Okay, I have not the time to debug it. It should work. And what we can do too in the backend is normally this would start a new span, which should be included in that trace I showed you, but it's not working. And the second thing you can do then is you can provide your own observation handler, which is a component that is called whenever you start your own observation like I've shown, and which then can do something on the starting observation and when the observation finished. And in this case, I wanted to log. I just restarted and let's see if it works now. Okay, let's switch and generate some stuff again. This is the UI backend. Yeah, and like you see now, the observation is working because every time I create a new session, I get this log create new session ID, and on stop, I see I created a new session ID, blah, blah, blah. And normally that should be shown in the traces as well. So what this observation API does too is not only should it add a new trace, it also adds a metric. So I can look for metrics, session ID generation seconds count, which is a metric which is produced by this observation. So with a single observation call, we now have a metric. We have this logs, the special logs. And as said, we should have even a trace. I can see if I have traces now. Let's see. Yeah, now here is it. Now, as you can see, our backend has one trace for the session ID generation and afterwards do the insert into the Redis. And that can be seen here. So the backend processing took 285 milliseconds. The first 52 milliseconds were eaten by the session ID generation. Afterwards, we put it into Redis, which took 1.3 milliseconds. Yeah. So this observation API produces now a trace, a metric, and a log. And what I did not show, or what I forgot when speaking on metrics, Grafana has a concept of dashboards too, and we can, for example, import a dashboard, and we can use this Spring Boot default dashboard, which has this ID. And if I just import it here, load, connect it to our Prometheus, and import it, we have a fully fledged dashboard of all of the default metrics that Micrometer in combination with Spring Boot produces. So we can see the backend is up for 2.5 minutes. It uses some heaps, has some open files. And there are even statistics about the logging system, the HTTP. If I would use a database, it would have database statistics too. And it even has JVM statistics out of the box. So we can see here our G1 old heap, the Eden space, and so forth. So let's switch back to the presentation for the last few minutes. So you have seen that. If you are not sure what's all related tooling in the space, there is the Cloud Native Computing Foundation landscape. And this is an example screenshot from all of the logging solutions. So I used Grafana Loki, but I could have used the Logstash from the Elasticsearch, or I could have used Splunk or OpenSearch or whatever. The same is true for metrics, which has an even larger landscape. As said, I used Grafana as a dashboard here and Prometheus, but there are multiple others. And for tracing, there are even some more tools too. So I use the OpenTelemetry stuff in combination with Grafana Tempo as a data source, but there is an Elastic solution. There's Jaeger, there's Zipkin, and there are some software as a service offerings too. And what I did not cover is stuff like alerting or anomaly detection. So you don't have to define your own baseline because the logging system learns it and produces alerts based on this. So there's even some more stuff. And so thanks for listening. The slides are available on our homepage. And if you have any questions which I can't answer now in the chat, reach out to me in your favorite social network or over mail. So thanks for listening. I hope you learned something new and it wasn't too confusing. Thank you.